It's that time again where we come your way with Pasco Made Easy with Senana. We are looking at core mathematics. We want to look at some set of questions on core mathematics, basically on sets. So remember that if you are learning any topic on sets in mathematics, this is the right video for you. Learn some questions, learn how to answer some of these questions. Remember to like this video, share this video, subscribe to my YouTube channel, and click on the notification bell so that you can get all the videos on time. Now let's consider this question. So the question says that if P is equal to 1, 2, 3, and 4, so it's a set with elements 1, 2, 3, and 4, write down all the subsets of P which have exactly 2 elements, right? Which have exactly 2 elements. And then B, we are to giving some sets A, B, and C. A is described as prime numbers less than 15. B is described as even numbers less than 15. And C is in the form of a set notation with the equality signs, right? Where 3 is less than or equal to S and is less than 12, where S is an integer. We have to list the elements of A intersection B, B intersection C, and A union B intersection C. Now let's consider how we can solve this question. So basically, A, we are given a set P, right? We are given a set P, and our set P is equal to 1, 2, 3, and 4, right? And we are supposed to list all the subsets which have exactly 2 elements. So we can have exactly 2 elements. We can have 1 and 2 as one of the subsets. So 1 and 2. We can also have 1 and 3 as one of the subsets. So we have 1 and 3. And we can also have 1 and 4 as one of the subsets. So we have 1 and 4. And we can also have 2 and 3 as one of the subsets. So we have 2 and 3. Then we can also have 2 and 4 as one of the subsets. So we have 2 and 4. Then finally, we can also have 3 and 4 as one of the subsets. So we have 3 and 4. So in the A part of the question, we are only asked to list them. So we have listed them. Sometimes they can ask you to find the number of subsets of a set, right? And that is where you have to use the n raised the power 2, right? Where n represents the number of sets or elements in a subset. Now let's consider the B part of the question. So the B, they've given us some elements. So here we must be able to describe the elements in terms of listing the elements in the set. So A is prime numbers less than 15. And we know prime numbers begin from 2. So we have 2. We have 3 as a prime number. We have 5 as a prime number. We have 7 as a prime number. We have 11. We have 13. Right, so these are prime numbers. It's less than 15, so we don't go beyond that. If you've forgotten what prime numbers is, we know prime numbers are numbers that have only 2 factors. So when we consider the number 1 has only 1 factor. It's only 1 that can go into it without a remainder, right? 2 has only 2 factors, so that is a prime number. So 2 has the factors of 1, so 1 goes into it without a remainder, and then 2 itself goes into it without a remainder, right? So mostly their factors are 1 and the number itself. And then the B, we are asked to list even numbers that are also less than 15. So basically we begin from 2, 4, 6, 8, 10, 12, and then 14. So we end here, right? And we begin from the 2. So even numbers are numbers that can be divided by 2 without a remainder. And then C, they've given us a set notation where we have an inequality. So it begins with 3 because it's 3 less than or equal to. So it begins with 3 and then it moves on to 4 because they are integers, positive or negative whole numbers. Then we have 5, we have 6, we have 7, we have 8, we have 9, we have 10, right? We have 11, so it's less than 12 because there's no equal to sign, so we end at 11, right? So we have listed the elements, that is for the B. Now we need to look at how we can list the element of A intersection C, right? So we want to list the element of A intersection C. So we want to look at members that are common to both A and C. So we see that both A and C, there's 3 here, there's 3 here, there's 5, there's 7, there's 7, then there's 11. So it means that we have 3, we have 5, we have 7, and then we have 11. So this is A intersection C. And then we are supposed to list the element of B intersection C. So basically, when we look at B, what are the elements that are common? There's 4 here, there's 4 here, right? And then there is 8, and then there is also 10. So we have 4, we have 6, we have 8, and then we have 10, right? So 4, 6, 8, and 10, right? And then we have 4, 6, 8, and 10. And then the we are supposed to list the element of A union B complement intersection C. Right, so for this, we need to consider A union B complement. So A union B all complement. And when we talk about A union B complement, first we need to know A union B. So what is A union B? We need to put both A and B together, right? So we have 2, we have 3, we have 4, we have 5, right? We have 6, we have 7, we have 8, we have 10 and 11, we have 12, and then we have 13 and 14. So this A union B. So what are the elements that are in A, B, and C that are not here, right? So we need to look for A union B complements, right? So it means that we will have 2 is here, 3 is here, 4 is here, 5 is here, 6 is here, 7, 8, 9. There is no 9 here, so it means that 9 is part of those A union B complements, right? So I think it's only 9. 10 is there, 11 to 14 is there. So A union B complement is here. So now we can find A union B complement intersection C. So we need to see whether 9 is in C, right? So when we look at C, 9 is also there. So it means A union B complement intersection C is 9, right? So basically in this question, we have been given questions that the set have been described for us, and we are asked to list the element and use that to be able to find some notations like A intersection C, B intersection C. So remember that you will like this video, share this video, and especially subscribe to my YouTube channel so that you will move on and look at another question on the real number systems when we meet again.